Hello everyone. Welcome back to the another session of foundation engineering. In this session, we will be discussing about earth pressure theories. Coming to this earth pressure theories, there are various theories for determining the earth pressures that are acting on a retaining wall, out of which Coulomb's theory is one of the most important theory used for determining the earth pressures acting on a retaining wall due to the backfill material. Generally, few theories like Rankine's theory are restricted for only homogeneous soils with smooth back surface of wall and for limited soil types, but Coulomb's theory can be used for all kinds of soil masses for determining the earth pressures. Coming to the Coulomb theory for a cohesionless backfill, the person Coulomb has given the earth pressure theory considering the sliding wedge which tends to break away from the rest of the backfill upon wall movement. The Coulomb theory takes into account the friction that will be developed between the wall and the soil by introducing angle of friction between them. According to this theory, when the wall moves outwards, the sliding wedge of the backfill material will be moving downwards and upwards. When the sliding wedge will move upward, the wall when the sliding wedge moves upwards and inwards when the wall is pushed towards the backfill. Next, the Coulomb has given few assumptions for determining the earth pressure theories for a particular soil mass. According to his assumptions, he stated that the backfill material must be dry, cohesionless, homogeneous, isotropic soil material, and the soil surface is planar and can be inclined. The third assumption given here is the back of the wall can be inclined towards vertical. The failure surface is a plane surface when passes through the heel of the wall. Here he is stating that whatever the failure surface will be considering an irritating backfill material, the failure surface must be plane and it must be passing through the heel of the wall. The next assumption is the position of the line of action of earth pressure are must be known. The last assumption given is the sliding wedge is considered to be a rigid body and the earth pressure is obtained by considering the limiting equilibrium of the sliding wedge as a whole. Then, according to his theory, he has derived an equation for the active earth pressures that are acting on a cohesionless backfill. Coming to this, you can look at the figure where there is a clear description given. Here A, B, E, and C. A, B, E is a sliding wedge which is under equilibrium, and the forces will be acting on this sliding wedge A, B, and E. The various forces that are acting on this wedge are there will be a reaction that will be taking place at an angle of phi dash and which will be at 9 inclined to this BE, which will be acting on this BE plane. There will be a self weight acting on the soil mass which is taken as W, and there will be a force that is acting along the plane AD, that is where the angle of friction will be, according to the cohesion, the angle of friction will be taking place between the wall and the soil backfill material. So the AB plane is the plane where there will be an angle of friction developed, since it is the plane where the wall and the retaining wall will be in contact with each other, and the angle of friction will be taking place with a force P and at an angle of delta. There will be cohesional forces C0 and C will be acting on the planes AB and B. So first, this kind of backfill and retaining wall conditions, when the alpha angle is at is equals to 90 degrees minus theta, the passive earth pressure or total active thrust is given as half gamma h square into sine alpha plus phi by sine alpha multiplied by under root sine alpha minus delta plus sine phi plus delta sine phi minus beta by cos alpha plus beta to the power of whole square. Under some conditions, The when the backfill wall is vertical and the surface of the backfill material is horizontal, that is when theta is equals to beta is equals to 0 and angle of friction is equal to angle of shearing resistance, then the total active pressure thrust is taken as Pa is equals to half gamma h square cos phi by 1 plus under root 2 sin phi to the power of whole square. The magnitude of the angle of wall of friction delta is a function of the type of wall material, the degree of roughness of the surface of the back of the wall, the type of the soil, the density of the soil, the hydrological conditions, vibrations and shocks and possible other changes and variations. All this will be depending upon the amount of direction of the movement of the wall. The success of the earth pressure theory will be lying between the correct determination of the values of phi and delta. It is not advisable to use an assumed or tabulated values of phi in earth pressure calculations. Next. Here, the one more important topic coming to this earth pressure theories are we for the whole determination of earth pressure equations. We will be discussing about the contact between the retaining wall and the backfill material. So let us know few points about what is a retaining wall. A retaining wall are relatively rigid walls that are used for supporting the soil mass laterally so that the soil can be retained at different levels on the two sides. There are various types of retaining walls which are classified as gravity retaining wall, semi gravity retaining wall, cantilever retaining wall, and counterfort retaining wall. So these retaining walls are diagrammatically shown here in the next slide. So this is a gravity retaining wall. So what is this gravity retaining wall? A gravity retaining wall will be depending upon their weight of stability. The walls are usually constructed for plain concrete or masonry. Such walls are not economical for this kind of walls are not at all economical for greater heights. The second one here we have a second classified type or second type of retaining wall here is semi gravity retaining wall. The size of section of a gravity retaining wall may be reduced if a small amount of reinforcement, whatever the line here inside it is shown, the line, it is nothing but the reinforcement provided near the back free. Such type of retaining walls are called as semi gravity retaining walls. The other type of retaining wall we have here is a cantilever retaining wall. A cantilever retaining walls are made up of reinforced cement concrete. The wall consists of a thin stem and a base slab cast monolithically. This type of wall is found to be economical for a height up to 6 to 8 meters. The last type of retaining wall we have here is counterfort retaining wall. Counterfort retaining walls have thin slabs known as counterforts. These are nothing but the counterforts spaced across the vertical stem at regular intervals. The counterforts ties the vertical stem with the base slab. Thus the vertical stem and the base slab span between the counterforts. The purpose of providing the counterforts is to reduce the shear force and bending moments in vertical stem and the base slab. The counterfort retaining walls are economical for a height up to 6 to 8 meters. So, out of the all classified types of retaining walls, the most important type of retaining wall where we will be doing the stability analysis is for cantilever retaining wall. The retaining wall must be stable enough to carry the pressures, forces, and loads acting on it from the with respect to the backfill material. So, for analyzing the stability analysis, we will be identifying the factor of safety for a retaining wall based against sliding moment, overturning moment, bearing capacity, failure, and tensions. So, for a cantilever retaining wall, this is the diagram shown here. The diagram shown here is a cantilever retaining wall, which is at a height of h, and the web is at a height of d, and the base is that the higher base point is having the width of 2 by 3 h. So this cantilever retaining wall, for a cantilever retaining wall, we will be calculating the earth pressure theories, the active pressure acting upon the backfill retaining wall surface and the soil according to the Rankine's theory. From this theory, the factor of safety against sliding is given as Fs is equals to gamma Fr by Fd, where the Fr is nothing but the sum of horizontal resisting forces and Fd is equals to sum of horizontal driving forces. So this can be further in depth written as Fs is equals to gamma V into tan phi 2 plus Bc2 plus Pp by Ph. Here Pp is nothing but the passive force in front of the wall, P, and Ph is given as Pa into cos I. Pa is passive, active earth pressure theory. The next factor of safety value is determined against overturning moment, which is obtained by F naught is equals to sigma mr by m naught, where sigma mr is nothing but the sum of resisting moments about 2 and sigma m naught is sum of overturning moments about the 2. Next, the according to the resisting moments given, and the factor of safety against overturning moment is also given as F naught is equals to m1 plus m2 plus m3 plus m4 so on by ph into h by 3. The next type of factor of safety value that is obtained against bearing capacity for a cantilever retaining wall is given by R is equals to under root sigma v square plus ph square. So where here the R is nothing but the resultant forces that are acting on the retaining wall, V is the summation of all the vertical forces that are acting on the base in equal magnitude, and PH is the horizontal force acting upon a retaining wall. Thank you.